Hey there and welcome back. So today we're going to talk about animations, or more specifically sprite animations. So before we do that, let's just confirm that we know what animations really are. It's going to make it easier for us. So you probably know this, but let's do this anyway. So animations is of course when we have something that looks like it's moving, but it's actually several pictures, one after the other. So here I've drawn 3 pictures of this little guy. One is a little different from the next. But if I try to sort of run them one after the other, we can see that it looks like he's moving. So that's the very basic concept of animation, right? One frame after the other makes something look like it's moving in some way. So this is what we have to do on the Commodore 64 with our sprites. The question is, how do we do that? So first we need to think about a few things when we're going to do sprite animations. We need to think about, do we need different animation types? So in other words, are there going to be different animations? Do we need to have an animation of an explosion? Do we need to have an animation of a guy walking? Do we need to have an animation of a big rock rolling around? You know, whatever. We need to think about what kind of different animation types we need. Or do we need different animation types at all? We also need to think about, do we want different speeds on the animations, or should all animations have the same speed? So the explosion, should that be the same speed as the guy walking, for example? Or do we want the animations to have different speeds? Then, when we get down to programming, we need to think about what sprite should have this animation. So, for example, the guy walking. What sprite? Should it be sprite 0, 1, 2, 3? How do we control those things? How do we control what animation we have for each sprite? And we also need to think about, how many frames does this animation have? Because like we saw with that stick figure just a moment ago, we need to have several frames for it to be an animation. So how many frames does this animation have? All right. So then the next question comes, when is the animation over? Well, if it's 5 frames, then it's probably over after 5 frames, right? But what happens at the end of the animation? All right, so we have done this thing with 5 frames. Now what? Well, maybe if it was the explosion and it ran with all 5 frames, then maybe we just want that sprite to go away. But if it was the animation of a guy walking, then at the end of the walking animation, we probably don't want him to go away. We probably just want to loop this thing. So could be a good idea to think about that we have different ways of handling the end of the animation. So as you can see, there are several things we need to keep track of. And we also need, now we get down to programming, right? So we need to think about all of these things in detail. First we need to understand the concept, but then when we have our plan clearly in our head, we need to do this with code. So here we are in my Sprite tables file. We've seen this before. It's a big file with a lot of tables. And every table has 8 entries because there's 1 entry for every sprite. Now for the animations, I actually have several tables just for that. So here, for example, here we have a table that's called the Sprite animation frame. That table is going to keep track of what frame it has 8 entries, right? So what frame are we currently at for sprite 0? What frame are we currently at for sprite 1? So on. So this table keeps track of what frame we are on. This next one keeps track of the animation graphic, so the actual thing from SpritePad, what animation graphic to show. Then I have some tables that says Sprite current animation type. So that's going to keep track of the animation type that's currently playing for a specific sprite. But I also have one called previous animation type. So I can compare do we have to change animation for a sprite, or is it playing the same animation that we just played? Stuff like that. We don't have to go into detail about that right now. But then we have something down here for animation speed. The way I handled this was just the same way they handled moving speed for sprites. So just by 2 tables, one called animation speed and one called animation speed timer. So I just compare those. But anyway, the point is that I have several tables here just to keep track of the animations for the different sprites. But I also have a file here called Sprite Animations. This is this is a file only for animations. So the way I do this is by making a label. I make a label for a specific animation type. Here we see anim player idle right. This is a very tiny little table for the animation when the player is idle and is facing right. I have the same thing when it's facing left, and we can see here that there are just 2 entries. Well, here's a little secret. This first one, that's the actual number from SpritePad. And the next one, 255, that's just a code that I made for myself. I just said, I'm gonna make 255. That number is going to mean the end of the animation. So I just decided I want number 255 to mean something in my game. And what is it going to mean? It's going to mean 255, that's the end of an animation. So I can check for this specific number when I'm reading animation frames, and if I see 255, that means that's the end of the animation. So every animation type has 255 here at the end. So this facing left and right, those are just 1 frames. But animation player walk right, this has 2 frames. And we of course end with 255 here. Same with walk left, but when we get to jump left and right, that's also just 1 frame. And I have something here when he's sad and happy and whatever. But we have to, we can't forget the other objects, not just the player. So here is animation for a monster walking left. That's also just 2 frames. Walking right, 2 frames, and so on. Here's an animation called monster confused. That's actually 1, 2, 3, 4 frames before we say that's the end of the animation. And we have a coin animating here. So different animation types here. How do I keep track of this? Well, if we go down here at the bottom of the file, I also made a few labels. And here I say animation player idle right. That's a label, right? So a constant, if you will. And I just said that's going to be number 0. So animation type number 0. That's player idle right. Player idle left, that's going to be animation type 1. Player walk right, going to be animation type 2, and so on. So I just give them numbers like that. So I can So I know they have different animation types, and now I'm giving them their own individual number. Then we get down here, because these tables up here, those were just keeping track of frames from Sprite pad. But then we have some tables down here. Now once again we're gonna see low and high byte, these symbols for low and high byte. So here's animation type low, animation type high. So how does this work? Well, let's take a look. In this table I say the low byte of anim player idle write. That's the anim type low table. And if we take a look below here, anim type high, the first one here is high byte of anim player idle write. So the same system that we have seen before with a low byte and a high byte table. But this time I'm keeping track of the different animation types. So if you see this label right here, the one that I'm taking low and high byte from, what is that? Well, it's this one. So every one of these tables are split up down here into low byte and high byte. So, and it's also important the order that I specify them here. Why? Well, it's because of this. Here I gave them different numbers. I'm saying animation player idle write, that's animation type 0. So the first one. If we go down here, we can see animation player idle write, that's the first one. So here it's important that I place them at the exactly right order. So this, for example, would be animation type 2, 0, 1, 2. So if I have think of a variable or a number that keeps track of animation type, and if that number is 2, let's think about loading X with 2, for example. Okay, loading X with 2, and we use that for this table, 0, 1, 2. So then we can get this. But of course, this low byte and high byte thing also means that, that I should have some 0 page addresses set aside for this, and I do. So here we have CP anim low, CP anim high. So I have 2 0 page addresses just for this animation thing. So that's of course working together with these 2 low and high byte tables. All right. So where is this actual magic happening? Well, before that, let's take a quick look at Sprite pad. So here I am in Sprite pad. Okay, so let's just remind ourselves that we're starting here with Sprite 0. So 1, 2, 3, 4, 5, 6. So that's what I was talking about with the number from Sprite pad. We can actually see down here, if you can see my pointer down here, what sprite number it is. We move over here and continue here. So also remember that we have this sprite pointer, that's the actual memory address for the sprite pointers for each sprite. We know about that. We also know about the sprite pointer index. So using the memory address for where the sprite graphics are crammed into memory, using that divided by 64, we get this sprite pointer index. So from that index, just by using that number, we can say, then we can start adding. So if, like we've seen, we have hexadecimal 80, then this is hexadecimal 80. Then we have 81, 82, 83, 84. So just so that we keep that in mind. Alright, so here are the sprite graphics for my game. I have exported them and I've put them in the code. Now what? So now I'm in my sprite library. Now, as we saw last time, this is the finished product and my sprite library is pretty big here. I've crammed everything in here that has to do with handling sprites. And remember, this whole thing with handling sprites, that's just a big loop. So I'm say handle sprites here. That's a subroutine, and I start that by loading x with 0 and handle sprites loop. So we're going through a lot of things here. Movement, we have we saw gravity last time, but then we get down here where we have handle sprite animation. So we go through all of these things, and at the bottom of the loop, then we are incrementing x, comparing x with 8. You know, if we haven't reached 8 sprites yet, then go to the top of the loop and do all of this for the next sprite. So that's how we can handle our sprites in the same way. We have just one big routine that's going around in a loop to handle our sprites like that. Alright, anyway, here we have the handle sprite animation part of the code. So how does that work? Well, as you can see, we start here by saying, has the animation changed? So are we changing animation, or are we playing the same animation? So for example, if we are walking, if our little guy is walking and then we do a jump, then I have a different animation type. I call it animation type even though it's just one frame, but let's just do it that way. So he's walking, having a walking animation, and when he's jumping, I have some jumping animation for him. So in that case, we're changing animation. And I check that here by comparing the current animation type with previous animation type. So that's just how I do it. I'm not going to go through this completely in detail. I'm just going to show you the concepts here. So when I load A with 0, store that in animation frame and in speed animation speed timer, that's basically saying that we reset the animation. If we say that the animations are the same animation, don't reset animation time. Don't reset animation. So if you are playing, for example, the walking animation, and that animation is done, the end of the animation, then and we're gonna continue playing it, then don't reset it. Yeah. Hopefully that makes sense. Yeah, let's not go too much into detail about that thing specifically. Let's just go through here where we say check sprite animation timer. So this is an important one. Now remember, I'm not teaching you this is how you make animations. You need to pay attention to every single line here. This is how you make animations. No, please remember, I'm trying to teach you different concepts, maybe give you some ideas. And the main thing to remember here is that we are using sprite pointers, right? So we need to change sprite pointers for a specific sprite. So we need to do that, but we need to do that at a steady pace. So that's the main point here. How you do it can differ a lot. Maybe you have some good ideas already, but I'm just showing you, I'm just trying to give you some ideas here. So anyway, we need to handle the animation speed timer. So in other words, how fast should this animation play? And like I said, I'm doing this the same way like I did with the speed of the sprite, the movement. I just have this speed timer and the actual animation speed, and by comparing those, I say if you have reached the timer or not. So if you haven't reached the timer, it's just a simple trick. I just increase the speed timer and I skip the rest. But if we have reached the timer, then we need to reset the timer and then do what we're supposed to do. which in this case is saying load A with current animation type. Alright, but we need to notice that we have comma X here. So everything we see in here, remember this big sprite loop, right, that we're in right now. For every time we go through that loop, X has a specific value starting at 0. That X is going to mean the sprite number. So starting at 0, that's going to mean sprite 0. So if this was the first run through the loop, then this comma X on all of these is going to mean sprite 0. So then if the loop goes through and the next time we come around here, then X would have gone up by 1. So then we're talking about sprite 1. Then it goes through again, and the next time we come around here, then the X is going to mean 2. So sprite number 2. So I just wanted to remind you about that. So we have to be very careful not to corrupt the X in this loop now. But anyway, for the current sprite here, the one in X now, sprite, current animation type. What's the current animation type of this specific sprite? Alright, so we go to the table that we have over here. Let's see, sprite current animation type. Here we go. So we say, if this was sprite 0, then it would be this top one, right? So we load that, and of course in that table there's a number for the animation type. So we get that number, and then we say transfer A to Y. So we loaded that animation type number into A, but now we're transferring it to Y. So now we can see that it's really nice to have two registers, helper registers, both X and Y, because right now X is super important. We can't change anything in X right now, because that's keeping track of the sprite number in our loop like that. But we need to index something, and we can do Y we can use Y for that. So that's why it's nice to have two of those. So X is keeping track of all the sprites, and we use Y for whatever in here. So anyway, I transfer A to Y, then I say load A with animation type low, comma Y. So here I picked up the animation type number, transferred it to Y, so I know what animation type number it was. Let's see here. Don't forget, I specified it here in Sprite animations. Gave all animation types their own number, right? So I say, for this specific sprite, what animation type does it have? Okay, transfer that to Y. Okay, from animation type low, comma Y, the animation type. Load from that table, the low byte table. Okay, well, that's here. If this was animation type 0, that's the first one, then that would be this animation player idle write. All right, load that and store that in that 0 page address for low byte, and do the same thing for the high byte. So we have gotten the low byte and the high byte of the animation. And once again, let's just remind ourselves that these kinds of labels are memory addresses, right? That's why we can take the low byte and the high byte from this label, because in reality, this is a memory address. All right, so we take the low byte and high byte, cram that into our 0 page addresses here. All right, then we say load A with sprite animation frame, comma X. So what is the animation frame right now for this specific sprite? Okay, so we get that one from our table here for this specific sprite. All right, and once again, now when we get the animation frame number, we transfer that to Y, Then we say load A with CP anim low. So the zero page thing that we set up just a moment ago here. Load that, comma Y. So remember, now this is a memory address for one of the animation types. But comma Y, what's that comma Y? Oh right, it's the current animation frame. So let's go back and look at our animations now. Let's say that it was, this monster confused. And we have set up low byte and high byte, that zero page thing with this animation type. So that's what we did here, right? Now this comma Y animation frame, let's say that was 2. So when we say load A with CP anim low, now we have constructed the memory address for, let's say it was this animation monster confused. But like I said, comma Y, the current animation frame. That means if that was 2 now, then we have 0, 1, 2. So 18. Alright, so 18, what's that? Well, when I set up these animations, I plotted in the numbers from SpritePad. So I could actually see here that 18, that's this frame. So from SpritePad, I just plotted in those different frames and put them in these tables. So anyway, now I have this frame. That's the number for a specific sprite graphic. Alright, so I load that. But first I say, okay, give me that. Now I need to compare that with 255, which, as you remember, was the code for end of animation. 255. Well, was that 255? Let's check. Ah, no, it's 18. We haven't gotten to that point yet, because if when we get down here, then it will be 255. So that will be the end of the animation. But anyway, right now it's just 18, so it's not the end of the animation. Not end of animation. All right, so we go here. Yeah, don't worry too much about these things right now. Not end of animation. So it's not the animation. All right. Well, then what did we actually load up here? Oh, that was the thing from the animation type table. So it was the number 18 for the sprite graphic. All right. Compare it here. Nothing has changed in A. We go down here. So A is still 18 now. So we're storing that in this table, sprite animation graphic, comma X. This table keeps track of the actual animation frame from SpritePad. So in this case, this frame 18 for this specific sprite that's in X right now. That's what this table keeps track of. So, okay, cool. Then we know what animation frame that the sprite has. And we say, now we have updated that frame, or we have placed it in that specific table. So then we can say increase sprite animation frame, so the actual frame number, which will mean that next time it will be the next number here in the table, unless we change animation type, of course. But anyway, now that table is updated. Now it says down here, done handle sprite animation. Wait a second. We just updated the table right now. We did not update any memory address. We haven't updated the sprite pointer yet. Alright, so right now, remember, right now we are in the sprite library. That's in our main code. I'm not updating sprite graphics directly in there, but I'm setting up what graphics they need to use. Alright, fine. So then what? Well, then we have this great thing called raster interrupts. Let's see. Yeah. So in raster interrupts, I have for every, you know about the raster interrupts, 50 times a second on my PAL machine. So I have something in there that's going to run this subroutine, update sprite registers. Now it does several things. For example, the thing we've seen before, updating the X and Y position of the sprite. But it also updates the sprite pointer. That's important for us now for the animation, because one of the last thing we did that we just saw in an animations routine was update a table called Sprite anim graphic for a specific sprite. So now we are loading that, not loading that number, and then as a clear carry, add with carry. So I'm going to add something. What am I adding? The sprite pointer index. So let's say it was hexadecimal 80 that we have been using now. So I take hexadecimal 80 and I add the number we put in here, which was 18. So that's this one. And if you remember what I said a minute ago, when we're starting up here, so from sprite 0, that's starting from that sprite pointer index. So think about it as, in our case now, hexadecimal 80. This will be hexadecimal 80. So by just using that index, we get this. But we need to add the number of the sprite graphic that we just figured out in our routine, which was 18. So sprite pointer index plus, so you can see down here, sprite 18. So by adding these two, we get this frame. Alright, so that's and then we're storing that sprite graphic, so 18 plus sprite pointer index, then we get the actual number that we need to put in the sprite pointer memory address for that specific sprite. Because this, in my raster interrupt routine, this is also a loop that goes 8 times through. So in my main code, I have this big loop that goes through my whole sprite library routine 8 times. So it goes through once for every sprite. That's in the main code. But in my raster interrupt, I have a little smaller loop, but it's the same thing. It goes through 8 times. So it updates the X and Y position, and like we just saw in our case right now, it also updates the sprite pointer. So, and of course, like you see down here, we increment X and comparing it to max number of sprites, 8, right? So, by doing those two things in a raster interrupt, updating X and Y and the sprite pointer, we are going to have we avoid having sprite tearing and sort of some weird graphical effects, because as we know, this routine in sprite in raster interrupt, that's a stable routine that's in sync with screen update. Alright, but before we leave this, let's go back to this update X and Y position. So let's just notice one thing here. We've seen this updating the X and Y position of the sprites, right? But let's notice here that here I load the X position table and the Y position table. We've seen that before. But in addition to that, I'm adding for the X position. This is not animation, it's just a little sidetracking, but it's important that you know about it. So for the X position, we need to add 24 before we update the actual memory address, because 24 that's the default sprite offset for the X position. So I think I mentioned this a while back, but when you see the sprite, the full sprite at the edge of the Commodore 64 screen, so when you see the full sprite right before it starts going off screen, so when it's right there at the edge, then that's X position 24. So if X position is 0 for the sprite, then it's actually off screen. For the sprite Y position, when we see the sprite at the very top, just before it starts going off screen, at the very top there, that's sprite Y position 50. So that's why we're adding 24 and 50 here, so that in the rest of our code we can think about, because we need to add this 24 and 50 to compensate. Oh, this is hard to explain. To compensate for the fact that those offsets are there, because we want to think about, for example, the sprite in the top left corner, that's 0, 0. That's the easiest way to think about this. And like we saw last time, that's going to make it so much easier to figure out collision routines for what row you're at, some stuff like that. All right, sorry, this was a sidetracking, but it's important that we know about these offsets, X and Y offset. So sorry about the sidetracking, but now you know. But anyway, the point here was that you see how we keep track of all these things using tables, and we have this big routine in our main code, and we have this actual thing that updates the memory address in raster interrupts. Yeah. Well, don't think we should go any deeper into animations right now, because the important part is that you understand the different concepts, and you might you might not even make it this way in your game, but just by understanding how it's possible to do the different things, you can make some sort of routine yourself. The important part is that the sprite pointer for every sprite needs to be updated. That's what's actually creating the animation effect. And of course you need to think about the speed of the animation. Alright, so before we leave today, I want to show you one more thing. Now this is also a little sidetracking. It doesn't have anything to do with sprite animations, but I just wanted to show you this. So you remember from last time this reaction library, right? I have different kinds of reactions here based on something that happens. Well, one of the things that happens in my sprite library, the big routine that we just saw. We have animation in there, we have movement in there, but in that movement part, there's a little section that checks if the sprite is at the edge. So if it's at the edge, then this subroutine is run. Check edge reaction. So that in that case, we load from a table called sprite edge reaction, X. So for that specific sprite. And then we jump to check reaction number. Now for the way I've set it up for the player right now is reaction number 3. Reaction number 3 is go to the next screen. That's what I've written here. So that might seem like some advanced thing. Oh, go to the next screen. How can we do that? That's really simple. So I have made a variable called sprite edge, and that's set in the sprite routine. When we go to the left edge, that's one number. Bottom, that's one number. Top, that's one number. Right, that's one number. So I have a number for whatever edge the sprite was at. So I load that here, and right here it's set up as constants, but you can think of those as numbers, right? So we're loading that variable, comparing it to up, down, left, right, whatever those numbers were. So just a simple compare, right? Branch if equal. So for example, if sprite edge, if it moved up here to the edge, and by the way, the way to find if it's an edge, you just check if the x position is 0, for example. I'm sorry, the y position is 0 if we're going up. So just doing that in sprite routine. And then this is run. Go one room up. How does that work? Well, we just load the room number and we subtract the map width. So by subtracting the map width, we're gonna go all the way up here. So just basically going one room right up like that on our charpad map, because one full width of the map is basically the same as moving one room right up. And then we just store that room number and we just load the room again. So that's how that's done. But in addition to that, if the sprite was moving up, we're going to the room up right that, then we need to say this sprite needs to be repositioned. So for if it goes up to the top of the screen, we're going to the room above and we load that room. Then we also need to reposition the sprite from the top of the screen to the bottom of the screen, so it looks like he's leaving this screen, but then we load a new screen and then we need to quickly move him down here so it looks like he's coming in from below. So by doing that, the way I do that is I load a with the bottom edge address of the room, that's a pixel address, -1, and store that in the sprite's y position. So hopefully that makes sense. Anyway, I just wanted to quickly show you that that's no mystery. Going left and right, that's even easier. Here I just say decrease room number and load the room number if I'm going left. So as long as you keep track of the room numbers, it's no problem. Alright, well, like I said, that was a sidetracking. It's just a little bonus tip for you today. But hopefully this animation thing makes sense to you. And like I said, just going through every single thing here line by line, that could take a week just itself, just making the perfect animation routine. So what I'm trying to teach you here is just the concepts of how we can make animation routines. And hopefully I did that here today. Alright, well, that's it for today. So I'll see you tomorrow. Bye bye.